So reading
2.1.
looks at asset allocation processes and the mean variance model and variations of the mean variance model. So let's just start out by first talking about some very basic terms with respect to asset allocation that we're already familiar with. The notion of strategic asset allocation was its long-term allocation based on investors' long-term objectives and constraints, and then tactical asset allocation, which is obviously a short-term decision-making process. The idea being to try to capture alpha. And then mean variance optimization is an approach, a standard approach used to construct a portfolio. It's based on modern portfolio theory, which was developed in the 1950s. And the notion behind modern portfolio theory is that if you put together assets that are less than perfectly correlated, the idea is that you enhance the diversification benefit of the portfolio containing those assets. And so in perfect markets, allocations that are made in this way are referred to as being mean variance efficient. And in such a market, so this describes essentially like the CAPM model. And you remember with the CAPM model, how did you construct the portfolio? It consisted of the risk-free asset and also a diversified exposure to the market portfolio. So those two separate portfolios were what the CAPM investors invested in. So this is because CAPM is also based on modern portfolio theory. Now, in order to be able to apply modern portfolio theory, you have to be able to estimate mean and standard deviation, and therefore you need good quality data. And in the context of alternative investments and trying to apply this model to those type of investments, because there isn't there's rather a dearth of data, there's a lack of quality data, it makes it very difficult to apply modern portfolio theory to alternative investments. So instead, when portfolios are sort of managed and constructed for alternatives, instead of finding an optimal solution, which is really what modern portfolio theory claims to do, right? Finding the optimal diversification, the optimal weights for your portfolio. For alternatives, portfolio management involves what's called satisficing. So it's not optimal, but it's satisfactory in that it's an acceptable solution, given that we can't find an optimal one. Okay, and then part of, as we said, modern portfolio theory is to estimate mean and variance. So here we're going to look at doing that with some basic formulas. Before we do that, we just note a term that's used to describe when essentially one portfolio is better than another with respect to risk and return. So the term that's used is dominates, and so the portfolio is referred to as dominating another portfolio if its expected return is higher and has the same level of risk, or it could have lower risk and the same return, or it could have higher risk and higher return. So higher return and lower risk. So any combination like that would basically describe one portfolio dominating another. With respect to investors that are risk averse, obviously they are not interested in taking risk or want to take lower levels of risk. And so that's what risk averse investors are. And when you're calculating expected returns and standard deviations in portfolios, you have to weight them in some way. And here we look at two formulas for weighting